All right, back for more trig substitution. Now, take a look at what we have here. We have 1 over the square root of 4 minus x squared. If we look back to our last example, we had a square root of x squared minus 1. And that x squared minus 1 had reminded us of the secant squared minus 1, which is equal to tangent squared. Well, now we have 4 minus x squared. Here's my thought process. If it's 1 minus x squared, it reminds me of one of these two. Okay, maybe it's 1 minus sine squared, which is then equal to cosine squared, or 1 minus cosine squared, which is equal to sine squared. Okay. Now, we don't have a 1 there. We have a 4. So here's my thought. If it was 4 minus 4x squared, we could factor out the 4 and still get to our 1 minus x squared. So here's what my substitution is going to be. Let me slide it over here. Let's let x equal. Now, it was that 1 minus x squared feel to it, so it could be either one of these. Let's just pick one and let's go for it. I'll just pick the top one here. Let's let x equal the sine of theta. Okay. But then that doesn't get us that 4 there, does it? Now, we got to square our x. So what's going to get me a 4 there when I square this? A 2 is going to get me that 4. So I'm going to let x equal 2 times the sine of theta. Okay, we'll work through it. We'll make sure it works out, but let's just do the rest of our substitution right now. Let's solve for dx. Well, dx d theta equals, the derivative of this would be 2 cosine of theta. So dx equals 2 cosine of theta d theta. All right, let's substitute. This is 1 over square root 4 minus x. What's x? 2 sine of theta squared times dx, 2 cosine of theta d theta. This is 1 over the square root of 4 minus, now let's square 2 sines of theta, which is 4 sine squareds of theta. Now here's that idea of I can factor out a 4 here. This is 1 over the square root of 4 times 1 minus sine squared. Sorry, work's getting a little angled here. And what is 1 minus sine squared? 1 minus sine squared is cosine squared. That's why we picked this substitution, so we get to go cosine squared there. So we have the integral of 1 over the square root of 4 cosine squared. Then remember, we have up here a 2 cosine squared. No, not cosine squared, just 2 cosines. There we go. All right. What is the square root of 4 cosine squared? That's just 2 cosine. Well, would you look at that? We don't get a much simpler integral than the integral of 1 d theta. And what is the antiderivative of 1 with respect to theta? That is just theta. This is theta plus c. Now don't forget that we're not done here. We don't want thetas, we want x's. If x equals 2 times the sine of theta, what does theta equal? Let's divide each side by 2. X over 2 equals the sine of theta. So we would take the arc sine of both sides. Theta is the arc sine of x over 2. So we have the arc sine of x over 2 plus c. That one worked out really well, didn't it? Okay, let's look at one more example in this video. Okay. The integral of 1 over x squared plus 9 dx. Now, you probably noticed right away there's no square root in this one. but I'm not afraid. It's going to be okay. Don't have to have a square root in there. X squared plus 9. Now, that kind of reminds me of x squared plus 1. Okay. And if it was an x squared plus 1, which Pythagorean identity would that remind me of? Which has a plus 1 in it? Well, actually, this one right here, this original. Tangent squared plus 1 equals secant squared. So I think this is the identity that I want. I want my x to be the tangent. So I have a tangent squared plus 1. However, just like that last problem, we don't have a 1 there. Just like in this problem, we didn't have a 1, we had a 4. We have a 9. So my thoughts are, if I had a 9 there, I could take that 9 and I could factor it out. Okay, and we'll be okay. So what's our substitution going to be? We're going to let x equal the tangent of theta. Then we're going to have, well, I almost did it again here. Then we'd have tangent squared plus 9, but we don't want tangent squared plus 9. We want 9 tangent squared plus 9, so we're going to sneak a 3 in there. 3 tangent to theta. That way when we square it, we get a 9 tangent squared, and we can factor out that 9. All right, let's solve for dx. dx d theta. Let's see here, and 3 would be in front. What's the derivative of tangent? Derivative of tangent is secant squared. So dx equals 3 secant squared theta d theta. All right, substitution time. This is 1 over x, 3 tangent of theta squared plus 9 times 3 secant squared theta d theta. You guys are going to get really good at this substitution using your identity and simplifying process, and probably just do this in 1 or 2 steps. I'm writing them all out. This is 1 over 9 tangent squared of theta plus 9 let's factor out the 9. This is 9 times the tangent squared plus 1 okay, and I hope by now you've noticed what's going to happen here. Beyond just the 1 and the 3 and the 9 reducing to a 1 over 3 here, what is the tangent squared plus 1? Tangent squared plus 1 is secant squared. So we end up with, lights are off, lights are on. Here we go. We end up with a, what do we have? 1 over 3 secant squared of theta times, right, because tangent squared plus 1 secant squared. We still have a secant squared in the numerator. That 3 reduced the 9 though. Times secant squared of theta d theta, and the secant squareds are gone. We just have the integral of 1/3 d theta, which is 1/3 theta plus c. And what does theta equal? Okay, come in here. Let's divide each side by 3. And then take the arc tangent of both sides. Okay, theta is the arctangent of x over 3. So this is 1/3 arctangent x over 3 plus c. Looks good. All right, I think I've got one more trig substitution video for you to watch, but you have plenty to work on right now.